Let's use matrix multiplication to look at the following cases. How to make a image look reflected. So let me start off with this. Again, all of this involves matrix multiplication. That's our original image, and this is an image which is reflected. Now, how did I get that? This was with the help of matrix multiplication. Along with the original matrix, I have the second matrix, and here is the dot product. How is this happening? That is something that would be complex as of now. I'll give a better and easier example. Now let's look at rotating the same image. So we have this to be our original letter, and this is a rotated version. It is not the same, it's a bit distorted for a reason which I am not able to explain as of now. I need to look into that, to be honest. So the one which I'm talking about, which will give us a good hint or good explanation of what we are seeing, is the following example. Rotating a triangle about the origin. So we have the triangle coordinates to be O, A and B. So basically we have it at, let me do this, origin, then A is over here, for example, while B will be over here. So basically this is our coordinates O, A and B. So let's rotate this in anti-clockwise direction by an angle of 30 degree. You guys can do it for 45 and 60 and even 90 and look into the answer. Okay, you guys can do that. That can be your homework. And again, all of this can be verified with a code and practically also. So let us do that and see. So we have the coordinates to be 0, 0, 1, 0, 0.5 and 1. So we need to rotate this. So using a particular matrix, this is the one. Okay. How did this come into being? That too has an explanation which we can't discuss as of now. So basically it is NP, sorry, not NP, cos theta. NP stands for NumPy. It is a library in our Python code. So sin theta minus of it and cos theta. So using this, we'll be able to do that. Now, if I want an angle of 30 degree rotation, so this set of values will turn out to be something like cos 30 degrees root 3 by 2, that is 0.87. You guys need to memorize all of these values. This is 0.5. This is minus 0.5 and this is 0.87. Now, we will, okay, I'll write it again over here so that I'll show the calculation as well. The same idea is pretty much used everywhere actually. So if you guys take up 90 degree and get this table, you can see those values over here too. Okay. So let's come back to this. So let's do the actual calculation. So what do we have? This is 3 by 2 and this is 2 by 2. So the resulting matrix will be 3 rows and 2 columns. 3 rows and 2 columns. Now, so we have the following data. This is C11, C12, C21, C22, C31, C32. So basically we are looking at C11, that is first row, first column. So all of this is 0, clearly 0 into anything is 0. First row, second column is C12, that 2 is 0. Next, C21, second row, first column. So this is 0.87. Then we have second row, second column. This is 0.5. Third row, first column. So 0.5 into 0.87 minus 0.5. 0.87 into 0.5 minus 0.5. That would be minus 0.065. And finally we have this 0.25 and 0.25 plus 0.87. 1.12. So the new coordinates will turn out to be this. Okay, so that's our prediction. That's our calculation. So let's see this. This is our original graph, as you can see. So this is our y coordinate, x coordinate, original and rotated triangles is present over here. So this is our original triangle. This is our rotated triangle. To verify this, you need to make use of the coordinates that will appear over here. So as you can see, this is 0, 0 approximately. Wherever the mouse goes, that's what is visible. Now I'm placing it at the second coordinate, the second point. It is 0 point. As you can see, it's almost 1 and 0.0 basically. Third coordinate is 0.5 and 1, as you can see. Now the rotated values, you can see that it's 0.67 and 0.9, that is 0.549, that is. Right, this is approximately 0.67 and 0.5. This is approximately minus 0.05 and 1.12. Okay, and that's what we got over here. The same is displayed over here. So you guys can calculate on your own and verify as well. We got the same set of answer. So this is how it works. It's as simple as that. It's a very simple concept, right? Of course, coming up with this was not easy. It would have been difficult, but they have come up and we know it. Now, let us not only rotate, let us scale as well. Let's rotate by an angle of 30 degree and scale by a factor of 0.5. So basically, if I take this as matrix T and this as R, so we are doing 0.5 times of T times of R basically. This is what we are calculating. So I can use distributive property, not distributive, commutative law, and I can multiply 0.5 with this or so on and so forth. Basically same set of values multiplied with 0.5, right? I hope you guys remember scalar multiplication, and the same thing I have done over here. So I have taken the scalar factor in the rotational aspect itself. Okay, so let me run this code. This is our output. Let me compare that with the original one. So can you see the difference? The rotation remains the same. So what is changing is, yes, the scaling. Can you see that? Right? So these are all the effects that we can generate with such small set of numbers, and we are able to understand so many things. So my request is, have different rotational values, have different scaling factors. It's easy to calculate, as you can see. Make use of the code, generate the graph, and you can learn about it better. Okay guys, yeah.